The experimental life energy device is set up so that the deflection needle is pretty much centered, and it's on a sensitivity of times 10, which is going to pick up even when I move my hand closer to it. That you'll see the closer I get. What I do here is I actually set it up with the glass with nothing in it, and it's totally dry. And that sets the 0 point for what otherwise is only going to be measuring the solution that's in there. And I'm using a standard that I use is 15 milliliters. But we'll be showing you more on that here in a minute. Here I'm going to be testing some of our tap water, which comes from our well. I'm pegging the meter. Okay, now there we have a reading, and it is a deflection of almost 70. But in any case, that just is giving us one reference at one volume of solution, which is our tap water, and it has equalized to ambient temperature over a period of a couple hours, just letting it to sit so that the temperatures were room temperature. And there's more to come. Hang in there. Here I'm using a X-Tech temperature reading with a probe in the water, which is reading 70 to 71 degrees. And I shut off the experimental life energy meter because the digital footprint that the device has in the meter is also has a radio frequency component that still is able to be detected by a sensitive device such as the experimental life energy meter. And here is the measurement in Celsius. Here I have the HANA HI 9813-6 on the pH setting. The probe is brand new. I haven't even taken the cap off once yet. But I have the solution from the pH calibration packet in this vessel here, which I keep separate from the other one. So when I do the testing, I can switch to that. But in any case, the pH solution is optimized for 77 degrees to be 7.03. But since it's 70 degrees in the measurement on the solution that I did before, then that changes that just a little bit, and it says that 6.99 is the reading that I should be setting the calibration for. And I'll be doing that here in just a second. Okay, I've taken the cap off the probe and put it in the water. It actually is the calibration solution for pH, and it's been sitting in there for a minute and a half. What I've got to do now is adjust the reading down till it hits 6.99, or 6.9 is about the most accurate I can get. And I'll let it sit for a minute, just still see if there's any drift, change in stabilizations. So now that the calibration is done, I'm measuring the tap water, and I rinsed off the end of the probe before putting it in the water. It's stabilizing around 8.2.3. So that's indication that there's a higher alkalinity, which never hurts your body. Acidity is worse. Okay, so it looks like 8.3 is the tap water from our well. Okay, here I'm measuring the pH with the calibrated HANA meter. And this is the Bionaid, and I use the 15 milliliters as my reference amount of solution all the time. So it's looking like it's around 7.7, but I'm still watching it because it was up at 8 before and it dropped down, but that's probably because of the previous measurement. But it takes a little time for it to normalize. It looks like it's stabilized. No, it's going down a little more. 7.6. Okay, I think that's pretty stable right there. 7.6. So pH is something that means per hydrogen. And I won't go into details, but otherwise now it's going down a little more. 7.5. But the body is prone to be more agreeable to the range in the middle. But alkalinity has a fashion of helping reduce acidity, so most of our foods are acidic. So it's a pH that is better for you, really. Here I have 15 milliliters of the Wayback water, and I'm testing the pH value with the HANA meter. And pH is a little closer to 7.2. No, 7.1. 7.0. 7.1, 7.0. Looks like it's stabilized at 7.1. Pretty close to 7. Yep. That's pretty good. This is a video of the calibration for the TDS, and the packet is a 1500 ppm solution to set it up, but because I'm at roughly 70 degrees, that it's slightly lower. Actually, it's 1397. So I have to adjust the meter down. Okay, 1397. Pretty close. It's stabilizing around that. It's hairline. Okay, now that I've got my TDS calibration done on the HANA meter, measuring the tap water from our well, and it's reading around 100 or 470 parts per million. And I'll tell you more about that and relevancy in another video. Okay, this is our Bionaid TDS test. And it's reading about 10. Here's a test of the Wayback water with the TDS metering. Oh, that one's registering. 231. Agitate. All right. 231 parts per million. Here's the calibration procedure for the conductivity in microsiemens using the HANA meter. The calibration solution is 1.413. Okay, 1.41. Here's the conductivity of the Bionaid. .05. Here's the conductivity of the tap water from our well. It's pretty low. 0.63. Here's the conductivity of the Wayback water. 0.35. Here I'm using the Milwaukee SM500 ORP meter, and I have a brand new probe for that too actually. And right now the microvolt reading is positive 381 microvolts, and that's good actually. In pools they'll put chlorine to raise the microvolt reading to kill bacteria, and so basically above a certain threshold bacteria gets eliminated. Here's a test with our tap water from the well, and the ORP is measuring quite a bit lower than it was on the Bionaid at 183 microvolts, and that's been settling for about 5 minutes now. Here's a test of the Wayback water, and after about 5 minutes of stabilization it seems to have stabilized at 225 microvolts.